The previous couple of videos I did last week, I showed how to prepare some stock that had gun drilled holes in it to turn the OD down concentric to the holes. This video is going to be the completion of that, to show how to actually physically turn the OD now that we've prepared the ends of the material to do it, and finish it to the size the drawing calls for. The turning I'm doing here, I'm turning it closer than the tolerance on the drawing, because it'll help in the milling aspect when I go to do the milling later, to indicate the part and to have it run truer in the fixtures, and also milling of the features in the part, so that you don't have to worry so much about the depths of things and such. So I'm taking a lot more care than would normally be necessary for this, in order to hold the tolerance of this OD within 1/1000th of an inch, if possible, on the turning. And this being Inconel material, it wears the inserts quite a bit, so you just can't set the offset and turn the OD and be done with it. So it's a little bit trickier than that. So I show a method that I use in this video to help counteract that wear on the inserts. So let's get to the machine work, or the setup and the machine work, and I'll show you what I do to do this, and the way this particular Integrex machine has certain features that make this a little easier to do. So let's get to the machine work. Here are the parts again. I've already turned the OD of 2 of them down, but these 2 I haven't done yet, and I wanted to make a quick explanation here, because I don't think I showed this in the last video. I prepared each end of the parts like this, like we saw in the last video, but I don't think I showed turning this down. What I did was I chucked onto this end in a chuck and put the other end down there on the center, and I manually skimmed off more than halfway down the part here. And I did do this on all 5 pieces, but I don't think I showed it, or I may have deleted the video. I did take video of it, but I can't find it. I think I accidentally deleted it. So that's basically all I did there, and I turned this down at a fairly rough feed rate. I don't know if you can hear that, or you can see the feed, so that it wouldn't chatter on me or anything, and I could get a good diameter that ran concentric down here to chuck onto. So looking at the next part in the spindle of the machine, I'm chucked onto that turn diameter, and I stuck the part out 21 inches here, and then I re-zeroed my Z on here, so I can turn down here a little more than halfway down the part, and then flip, and then turn that end, then flip the thing around and stick it back in and re-indicate it here, and run the same program for both ends of the part. So that'll be kind of nice to do that. And I think the video that I'm showing this, I've actually turned the end that's in the chuck in that part of the video, so that's what you'll see. So I just want to make that explanation, because I don't think I showed that in the last video. Just finished taking two what I'll call rough finish passes on this part because now we've got to mic the diameters at each end of the part and decide how much taper we've got in here and adjust the tailstock over here to take out the diameter change by actually cutting a taper in the part. And because we've taken already two passes with that insert, it's not going to be able to take another one, so we've got to index the insert, come down here, take a little trowel cut here to verify where we're at before we actually change the offset of the tool. And you would think that's it, but it's a little trickier than that, because as the tool cuts down to this end of the part, it wears the insert, and so it actually cuts smaller in diameter down here when the insert's fresh, and it gets bigger as it goes down. So you kind of have to make sort of an educated guess at how much to adjust this tailstock and over here to get it to cut a straight turn. So that's where the trick to this is. So first we're going to index the insert. Then we're going to mic these diameters here and adjust the tailstock and take another cut, but we're going to intentionally leave it a little bit big to so we don't cut it undersized in one end or the other. And then we might have to make one further adjustment to the tailstock over here and then take our final cut, sort of making a guess as where our insert's going to cut and what side. So let's get to that. Okay, this end of the part looks like about 6.5 thousandths bigger than nominal. Nominal would be there, and so we're 6.5 big on this end, which is the tailstock end of the part. Okay, down at the chuck end, our turn ends about right here. This end of the part's already been finished, so this should be pretty close to 1 3/4 inches. Okay. Might be a couple of, let's see here, be a couple of tenths bigger, but it's real close. And we want to match that if we can, or get very close. So this end of the part looks like it's about 1/2 thousandth bigger. It's, well, maybe about I don't know if you can see that. So it's about 5.3 thousandths bigger than nominal. This, of course, being the nominal size. So we were right there. Kind of hard for me to do this. I'm not used to miking this way. I'm doing it for the camera. So let's say 5.3. So we have a spread here. We're smaller down at this end by, we'll say 7/10 plus almost 1,000, a little more than 1,000th of an inch. So we have to adjust the tailstock up just a little bit. But there again, it's gonna, with the new insert, it's gonna cut smaller down at the tailstock end. So we might just run one finish pass at this point and see where we're at. This end down at the chuck This end down the chuck was a little bit smaller when I mic'd it, a little more than 1/1000 of an inch smaller than this end, which might be good. So we're going to run one more finish pass with the new insert in the tool, and we're going to see where we're at. We're not going to change the adjustment of the offset. We're going to take a little test cut here, maybe about 1/4 inch long, and then we're going to stop the machine and mic it just to verify where this new insert is. And once we establish where that is and what we're safe in adjusting the offset, then we're going to adjust it, but we're still going to try to leave it a little oversized and take the cut down here and see how it's turning, because we took a couple of passes to get down to this level, and of course the insert wore, and so we can't depend on where it's going to cut, taking this small amount to get to the finished size. So first we're going to verify the insert, and then make a small adjustment to the offset and take a cut, and hopefully we're going to be within a few thousandths of the finished size, and then we can decide what we got to do with the tailstock here to adjust it to get us a straight turn. Okay, here's our straight little turn, just a test cut, just to verify where our new insert is. So let's see where this actually measures out to be. Okay, it's saying we look at this, we're like 4.5 thousandths bigger than the nominal right now. So we can make an adjustment. We probably could safely make an adjustment, maybe 3 thousandths of an inch down, and cut it, and then see where we're at for our last cut. And hopefully we'll be 1, 2, 3, will be 1/1000th and a half big still, but we want to see what's happening at the other end of the part down there at the at the headstock end of the part. Here's the tailstock end after our first finish cut. We're looking at here, we're looking at 1/1000th and a half above the nominal size right here. So that's just about exactly where we figured it would be after making our adjustment to the offset. Now let's see what the chuck end of the part looks like. Here's the chuck end of the part. This is our turn, ends about right here. So let's see where we're at here. I don't know if you can see that or not. Let's see. We're in exactly the same place as the tailstock end. So it looks good. I think we can rerun this finish pass, and hopefully it'll cut straight. But usually the tool will cut a little bigger at the tailstock end now that it's worn, as it went all the way down here. So we can make a little bit of an adjustment here, I think, and it'll make us straighter. If we actually raise this tailstock a little bit, we can raise it and take a little test cut down here at the end of the part, because the part is already oversized on the length, and also the one end gets a little bit of a taper to it, so the material would be cut away anyway. So we can do that and just run a little test cut here and make sure that we're at the right diameter after we adjust the offset. The way we go about this is stick a mag base on here, and we adjust this. We put this indicator down here on the end of the part and adjust it for a 0. This is a 10th indicator. Adjustment on its tailstock down here. You can loosen these clamp screws here, and when you turn this with a wrench, it actually adjusts this up and down because it's off center. The spindle of the tailstock is off center in the quill, and so when you rotate the quill, which is what this mechanism does here. It raises and lowers this. It only adjusts in a very small amount necessary to take out tapers when you're turning, but in a way we're intentionally forcing it to turn somewhat of a taper here because of the wear of our insert. So we're going to adjust. I'm going to raise this here on this end about 1/2,000th of an inch, and then we're going to take this little test cut after we adjust the offset of our tool. The insert is worn taking that cut down there, so, and it's been my experience with this insert that it'll cut the next cut pretty much the same size as it's left off here at the chuck end of the part. So if we adjust this up to where we're getting the same diameter when we adjust our offset for the appropriate turn down here at the chuck end of the part, that will cut a pretty straight turn. So that's what we're going to do. We're going to turn this, and we're going to actually raise this here 1/2,000th on the indicator, and take a little short test cut down here, only a 1/4 inch long or so. We took this little short test cut up here, only about 1/8 of an inch actually. We're going to mic this here, and it looks like we made our adjustment for the headstock or the chuck end of this to be on the right on size. We went down 1/1000th and a half like we mic'd earlier, but see down here we even moved the tailstock up 1/2,000th, but see we're still a half, so that changed. We're still 1/2,000th above nominal down at this end of the part, which I could turn it at that and we'd be plenty good. But if we move it up about another 1/4 of a thousandth here, we should even be straighter. So I'm going to make that adjustment just the same way we did a second ago with the 10th indicator on here, and adjust the tailstock. We're going to come up another couple of tenths here and see if we can get this right on the nominal. Tailstock end, after our second finish cut and hopefully final finish cut, we're I'll get this mic on here, right? We're like, oh, maybe about 3/10 above nominal on this end. Here's the chuck end of the part. This is where we left off from the other end where it was turned up to here. Somewhere right in here is where the turns overlap. You can barely even see where they happen. And so that end was about, as we measured before, about 2/10,000ths bigger than nominal. And up here, according to this, we're about 1/2,000th bigger than nominal. So that's pretty good. I'm not even going to mess with this further. I'm trying to hold this within 1/1000th of an inch of nominal dimension, which is where the 0 is here, which is 1 3/4 of an inch. And I'm pretty happy with that. I think I'm going to leave that alone. The middle of the part, it's looking pretty much the same as the chuck end of the part is. It's about 1/2,000th, maybe a little bit less than 1/2,000th above the nominal 1 3/4. So that's good. I think we're going to leave so that's going to be it for this video. I know it's been a little bit long-winded of a video, but I felt like this was worth showing how I go about doing these things. I also want to say thanks to all the new subscribers and all the nice comments that people have made on the videos. You know, when you put a lot of work into videos and then people make good comments about them, it really makes you, want to do more videos in the future. So thank you for all the nice comments. I really appreciate it. And also, if you got this far in the video, thanks for watching. Thanks. Leave this alone here. It's close enough.